So, additive manufacturing, as I have told, additive manufacturing and 3D printing, it might be, or yeah, that's so, that it is a new course for all of you that you might have studied as compared to conventional courses. Okay, and this course is still under development. A lot of research is going on, and there is a lot of scope for for all branches of engineering, including your civil engineering, EC, electrical, electronics. Although students are not from electrical in the current batch, but there is a lot of scope for all the branches, including the uh, architect student. Okay, so in module one, we have in module one basically we have syllabus. So all the student, those who have done course with me previously, they are aware that I usually maintain a website with my personal name. Okay, and here you will be able to find all your syllabus, lecture notes, as well as YouTube recording of the of this session. Okay, of these lectures. So here in module 1 we have introduction to additive manufacturing, then distinction between AM and CNC machining, steps in AM. So we will today's discussion we will start with the module 1, and the first topic is introduction to additive manufacturing. Okay, so the question is, what is additive manufacturing? Okay, so as the name may give, certain indication, like the name is additive, so something maybe adding upon adding, addition of something, maybe you can say addition of materials. Maybe we may not be able to understand the process going on, but the meaning as itself is indicating that something we will be adding, and we are not aware that how we will be adding. Okay, so before going into the in the in depth, or detailed discussion about the additive manufacturing processes, here I have put some figures, or you can say these images I have taken from the internet. This just a second. Just a second. Yes. Yes. So here I have taken three photos from the internet. You may find n number of, or multiple number of figures if you go on internet and type the images, image search about additive manufacturing machines. Okay, so these machines are commonly known as 3D printer, but as a curiosity for for all the student, I have taken these figures, these images, so that you are aware that how these additive manufacturing machines looks like. Okay, so all, or in rough term you can say all these are 3D printers. Okay, so there is one printer by MakerBot, one is by Race 3D Pro, and another one. Okay, so these are the three printers, and this is only to show you so that you are aware that how this printer looks like. Okay, so here you can see in all these printers, you can see there are some printing chamber is there. Like in our 2D printer, we print on a horizontal plane, and you get the printout. But in the case of 3D printer, here also you are printing material and you are getting 3D output. Okay, so since the output is 3D, so it may be a it will be in the form of some object. Okay, and that object will be printed based upon the geometry that you are creating in your computer model. Okay, so just for to make you aware about how these machines looks like, how these additive manufacturing or 3D printing machine looks like. I have taken these in these photographs, and later on we will discuss what actually additive manufacturing machine is. Okay, so let me go ahead. And the first question, it is still not answered, that what is additive manufacturing. So the additive manufacturing is a method in which the part is created or a product is created by a layer uh, upon another layer, or you can say a layer is added on another layer. Okay, so how this is done, that we will discuss in the coming time. Maybe today itself we will be covering how these layers are added, or how these layers are added, or one layer is added upon another layer. Okay, but the end result is that this process is additive, and you are adding one layer of material over another layer of material. So for this, what is the, you can say, first step, what is expected, that we have to, conceptualize, or we need to, create a CAD model of your desired component that you wish to print. Like in the case of 2D print, what you are doing, you are writing text in Notepad, or maybe WordPad or TextPad, wherever you are writing, you are writing something, or you are creating something on your 2D paper, you can say. Okay, and you are printing it through a normal printer, through which you are getting your printouts. Okay, similarly in the case of 3D printer, we have to create model that we want to print something. Okay, so that model we have to create on the computer. It has to be created in a solid modeling software like AutoCAD, Pro-E, CATIA, or SolidWorks, whatever you want to use, you can use. Okay, for modeling of the product which you want to print. Then these steps I will be discussing in the coming slides. Okay, so the commonly yes, the one thing that I forgot to tell you, there are, numerous terms that are used for additive manufacturing. Okay, so the first term, that is rapid prototyping, direct CAD manufacturing, desktop manufacturing, instant manufacturing, CAD oriented manufacturing, layer manufacturing, material deposition manufacturing, and material addition manufacturing, solid freeform, uh, solid freeforming, and you can say there are other terms also. I have listed a few, like rapid manufacturing, or digital manufacturing, or there are, you can say, various terms that are used for additive manufacturing. But the recently accepted name is, or you can say commonly accepted name is, additive manufacturing. Nowadays, people are using the term that is additive manufacturing, or you can say one term that is also missing, that is the 3D printing. Okay, so all these terms usually stand for additive manufacturing. Okay, so you need not to confuse by what is desktop manufacturing. It is again it is a additive manufacturing process. Yes. So till now, I hope you are able to visualize that what will be the role of these additive manufacturing machines. How it is quite clear that we will be creating 3D object using these machines, and how we will be creating these 3D object, that we will be discussing. What are the, process step, or the additive manufacturing process chain through which these products are created. Like there are 8 established steps in the additive manufacturing that are commonly accepted worldwide. Like first, we have to conceptualize the product. That we have to, create the CAD model of your product that you want to print. Okay, so let me open my camera here. I hope yes. So I guess you are able to see my face. Are you able to see? Yes. Yeah. So that if I wish to show you something, that I can show you. Okay. Yes. So suppose I am having a one bowl in my hand. I hope it is visible to all of you. And suppose you want to print this bowl. Okay. So what will be the required? Uh, you have to create CAD model of this particular component, and then you have to print it using the 3D printer. Okay. So in that case, what will be the your primary objective uh, as per these 8 steps are concerned? You have to first conceptualize the model, that what component you are supposed to produce, or you want to print using your 3D printer or additive manufacturing machine. And likewise, you have to gather all the data, like what is the dimension, what is the size, where are the curves, and where are the circular component, the way you need to all the data that will be needed to produce this model in your CAD modeling software. Okay. Yes. So after this, yeah, yeah. Let me disable mic for all of you. Otherwise, these sounds will not stop. Okay. Yeah. So yes. So the first step is conceptualization, or you can say the creation of your product that you want to print in a CAD modeling software. Okay. Then in all modeling software, we have facility that we can convert these files. But like every software has some file extension for the part created in its. Okay, like for AutoCAD we have TWG, and for SolidWorks we have different extension for KTI and for ProE. Okay, depending upon the modeling software you are using, you get the file extension. But for using for printing this product, what we have to do, we have to convert it into a some common format that is acceptable by your 3D printers. Okay. So the most of the 3D printer accept STL format. Nowadays they are accepting other file extension too, but let us continue with STL, like for the case of your conventional 3D printers do. They all accept STL file format. Okay. So what we have to do, using that particular solid modeling software, you have to convert that model of your part into STL format. Then the second step after this, then third step is transfer and manipulation. Okay, I will be discussing these steps in coming slide. Today we have the whole lecture on the discussion on these steps. Okay. Then the third step is transfer and manipulation of STL file on your additive manufacturing machine. Then the fourth step is machine setup, then build. Fifth, part removal. Sixth, post processing of your printed component. Then when your product is ready for the application wherever you want to use your product. Okay. So yes, so here I was trying to visualize to show you through one bowl. Here we have a cup, and what you are doing is, suppose you want to print this cup, you have to create a solid model, or you can say model it in a solid modeling software. Then you have to convert it into a STL file. Then you have to transfer it to your 3D printer. Then you have to set machine setting, and then you have to print your component. and after that you have to remove it, and you need to do post processing. Okay, so we will be discussing these steps in now. Okay, so the first step is conceptualization and 3D modeling of your part. Okay, so we need to gather all the 3D information related to your component that needs to be printed using your AMSE. So we need to gather information related to your geometric data, and then you have to create the model 3D model in a solid modeling software. So yes, okay, and I hope those all of you might have done the engineering graphics lab in your first year course, and there you might have studied how to create CAD model, 3D model of any, or modeling you might have studied. Okay, you might be aware how to create 3D model in AutoCAD or SolidWorks, or any other software that you might have used during your first year course. Okay, then the second step, as I have told, the conversion to STL format. So STL here stands for stereolithography, and not most, almost all the CAD 3D CAD modeling software have this facility that you can create your STL file of your model using, or you have in some software you have option like import as sorry, export import as STL or save as STL. You have multiple options depending upon the solid modeling software you are using. Okay, yes, so let me show you one example. I have one STL ready-made created for you, like for demo. Yes, I have one STL file. Let me open it in my system. So here you can see I am having one STL file of yes, I hope it is visible to all of you. So this is your STL file, and here you can see couple of things. Okay, your because it is not showing the actual software in which it was created. Okay, let me enable mic so that if somebody is having any doubt in between, he or she can ask along. Okay, so you you are having you first step was to create the CAD model of your part. Suppose I wish to create a universal coupling. Okay, so I have created CAD model, then I have converted it into a STL file. So this is the STL files corresponding to your universal coupling. Okay, so hope it is visible to all of you. Then the after the STL file, what is the next step? Let us discuss now. So we in STL file we will discuss what is the the structure of the STL file. We will be discussing in coming lectures. Yes, yes. So once this we get yes. So then once you have got your STL file, what you have to do, you will send you will transfer this STL file to a additive manufacturing machine. Okay, nowadays it is standardized. Otherwise, usually what we have to do in past, we have to transfer it to a slicer software, where you can, slicer means something where you can create layer of part. Okay, so we have to use external slicing software but nowadays we are getting we can directly transfer your STL file to your 3D printer and there you can slice your 3D 3D product. Okay, so once the STL file has been generated, it can be sent directly to the target AM machine. In most of the 3D printers, we have a option that is print, or sometimes it is replaced by, it is written as build. build. So what it does, it does many things. Like first, it as soon as you click on print, it slices your STL file into thin layer of your data. Okay, how this data is saved, that we will discuss. Yes. Okay. So let me demonstrate it. Otherwise, you will not understand by speaking only. So like I am having uh, one software that is Cura Ultimaker. Okay, so it is a one of the manufacturer of your 3D printer, and even though previously slicer software was used to be supplied by this company, that is Ultimaker, and the slicer was named as Cura. Okay, you can find many other slicing software on the internet. Most of these slicing software are free. Okay, so I have one STL file which is corresponding to your universal coupling, and now I have to transfer it to your additive manufacturing machine. So file, open, and yes, here it is saved. So yes, I am opening this file. Let me open it. Yes. So I guess it is visible to all of you, and you can see this file has been transferred to your additive manufacturing machine, that is Ultimaker Cura. Okay, I have not installed printer because it is saying add printer. I am not having printer on my connected to my laptop, but for demonstration purpose I have installed this particular interface so that you are able to understand how this slicing takes place in the case of 3D printer. Okay, so here you will find lot of options like you can change the view, front view, uh, then top view. Okay, so let me remain it in 3D view. Okay, so here there are a lot of options, and you can see here if you want to move this component or you want to scale it, because this is looking like it is capturing the whole bed of your printer. This is the bed of your printer. So what you can do, let me scale it by 75%. So you can see the model has been scaled, right? The site has the size of this model has been reduced to 75%. Yes. Now there are other options like if you want to rotate it, you can rotate it so that you can decide the orientation for the printing during the printing, in which orientation you want to print it. Like suppose I want to rotate it like this. Okay, so you can rotate it like this, you can rotate it. Okay, so let me do it. Yes, so you can reorient depending upon your requirement, in which orientation you want to print this particular component. Then we have options like you want to print it with support or without support. So let me slice this model without support. It is normal mode, I have not selected as support. Okay, so first I will show you how we can get slice, how we can create layer of this particular 3D object, that is the STL file of your 3D object, without support. We are not creating slice data for with support. Okay, so here you can see there is an option slice it. Okay, so but before this, what we have to do, what will be how this material will be sliced, what will be height of one sliced layer, or you can say what will be the layer height. So there are option here, you can see in every is your slicer we have these options, like you can control the laser height, so or you can like you can still uh, change this layer height. You may choose depending upon your requirement, and here like I have chosen 0.06 mm. Okay, then wall thickness 1 mm. These data you can change depending upon your requirement. Okay, so let me slice it so that you are able to understand what does this slicing means. Yes, so the material is getting sliced, because I thought instead of explaining on your PPT, you may not be able to get the actual touch or actual feel how this process happens in the case of your 3D printer. Okay, so here you can see it is showing that 2 days 12 hour 21 minutes. So it is representing that this much time will be required when we are using this much layer height. Okay, so our layer thickness was 0.06 mm. Okay, it was less than a millimeter. Okay, it was in, you can say, micrometer. Okay, so let me save this data. I'm saving this data for demo, sliced data. Okay, let me preview it so that you are able to uh, yes. So now uh, it is showing the preview of your actual sliced data, and you can see here how many layer are there. Here if you can read, it is representing 1748. So there are you can say 1000. Let me zoom it for more clarity. Yes, yes, and let me set the view for more. Yes, yes. Okay, so here you can see this is representing 1748 layers of your material that will be deposited. And here you can see you can control the you can see the visualization corresponding to your layer. Okay, like from layer 1 to layer 1748. Okay, and how these layer will be printed, let me show you. Yes, so like I am showing you layer number 1, how this layer will be printed. Let me click on the play button, and here you can see one nozzle is printing. uh, I'm not sure whether you are able to visualize or not, or I have to zoom it more. Can you see? Yeah, okay, let me show it with more. Yeah, so it is for more clarity. Yes, you can see how this 3D printer is printing your first layer. Okay, so likewise it is showing that how much time it will take. It will take 2 days 12 hours. Okay, so you can say 2.5 days, two, 2 days 12 hour and 21 minutes in order to print this your universal coupling. Okay, so even though I'm not showing you the real printer, because it is one printer is available in our department, but I'm not sure whether it is working or not. But I hope you are able to get the feel how this printer will print your product layer by layer. Okay, so let me show in some fast mode, like I have shown. Like this is the creation of your first layer, and here you can see the data corresponding to any layer by moving. I am moving my mouse, and suppose I am showing you layer number 700. Okay, so you can see the scan you can see here the how your this your layer number 700 will be printed. Let me play. So yes, yes, yes. I couldn't get you what you want to ask after 3D. Yeah, okay, that we will address. Okay, yeah, okay. Obviously, it is required, but we will address how much it is required and when we have to do and what is the actual. Yeah, okay. Uh, y- yes, yes. You can go. Yes, yes. Any machining operation during the post processing you require, it is possible. Okay. Yeah. So this is how I hope you are able to get how this printer prints your 3D CAD model and how this model is created in your additive manufacturing machine. Okay. So which are commonly known as your 3D printers too. Okay. So here you can see. Some staircase type of effect is there. Okay. So this is because one layer is added upon another layer, so the surface may not be smooth, uh, that much smooth, but the smoothness will depend upon the layer thickness. Okay. So you can make it more fine, you can make it like 0.001, and then you have to again slice this data, but it will take time. It, the printing time will will increase depending upon your layer height. Okay. Yes. So yes, let me come here again on the PPT. So what we are doing in the step 3, we are transferring your STL file directly to your additive manufacturing machine. Like this, like in our example, we have directly transferred our STL file to Ultimaker 3D printer. Okay. And but in some cases you may need some external software where you need to create you need to slice your STL file using some external software. Okay. So nowadays this limitation is not there, but previously in some in development phases it was there that people used to create sliced data on an one slice software, and then they are transferring this sliced data to a additive manufacturing machine. But nowadays it is clubbed and you can perform the slicing on your additive manufacturing machine itself. Okay. So in additive manufacturing, the user may wish to reposition the part or even change the orientation. As I have explained, we can change the orientation here. You can reorient it depending upon your requirement, and uh, you can print on the orientation in which you want to print. Like we can rotate it in the desired direction wherever you want to rotate it. Okay, like let me select. Yes, so you can put it in the orientation desired by you, and then you can slice the your STL file depend on the orientation which you have decided. Okay. Yes. Tell me again. Uh, No, no, the slicing direction will remain always horizontal. Okay, let me show this again. Okay, so suppose I have oriented your object like this. Okay, so then it it will be printed in this direction only. Let me slice it. Okay, it will be sliced, and maybe because the orientation is not proper, the printing time will increase. So let me see how much time it is showing. Yeah, it is reduced. It is not increased actually. So the slicing time now, it is showing 2 days 8 hours. Earlier it was 2 days 12 hours. Okay, and let me show the preview of this slice data. Let me save again. Data 2. Okay. So sometimes the result may be something different than what we guess. Okay, like I was thinking that the printing time will increase, but it is showing it has decreased. And here you can see number of layers has increased. It is showing 3250 layers, and let me show you the yes, yes. So this is showing you the how this layer are being printed. So here you can see the orientation of your component does not have any relation with the slicing. Actually, the slicing always takes place in horizontal plane. So in whatever orientation you are putting, your slice data will always be generated in horizontal plane only. Okay, so one horizontal plane over another horizontal plane, then another horizontal plane, and that accordingly the data will be generated. Okay. So you can reposition the part. You can even change the orientation, and even you can put your STL file into a particular specific location within the machine, or within the bed of your printer, wherever you want to print your component. It is quite common to build more than one part in a additive manufacturing machine at a time. So if you are having space, you can print multiple component on, if space is available, you can print multiple parts or multiple product on a single additive manufacturing machine. You can print, yeah. This may be multiples of the same part. You can print multiple component of the same part. Maybe you want to print 2 3 component, or 2 3 model of the same universal coupling. You can put at different locations on the bed, and you can click on the print button. Yes. Then yes, then there are once you once you have transferred your STL file, and you have created, or you have sliced your data, then there are some setting, or you need to set up your machine related parameters, like these parameter may be the bed temperature. Like, let me see whether these options are available in this particular software or not. Yeah. So there are other parameter, like you can see fan speed, cooling, and it is showing some other infill density, how much 20%, 40%, 60%, and then there are other parameters too. So these are the machine related parameters, and like if I have not enabled printer support, if you want to enable it, then you can yes, like this option is when you want to print a component with support. Okay, so for support data also you have to give machine related input. So all these comes under the machine setup. All AM machine will have at least some setup parameters that are specific to that machine or process. Some machines are only designed to run perhaps one or two different material. Okay, so in 3D printer you will find this limitation that you cannot print any material on any printer. Okay, like yes. So because when I saw this diagram, when I have shown this diagram, so some of these printer are related to, you can say, PLA. This may be again PLA. This may be corresponding to your metal metal materials. Okay, so here these are you can say limitation corresponding to the printer. Like you cannot print materials, metals on the printer which are designed only for plastic or ceramic or whatever the material. Okay, so you can say there are the limitations of that particular machines. That machine may run only for one or two materials, or maybe the material which is yes. That there are, different kind of materials are used, that we will discuss during the technology discussion, when we will discuss types of AM machine. Okay, then there you are having even powder, you are having filament also, you are having liquid material also. Okay, so that we will discuss during the discussion on material. Okay, that yeah, separate lecture is designed for that. Okay, so let us not focus what kind of material will be used, that we will be discussing in more detail. And but the limitation is that each machine cannot print all material. Okay, any machine cannot print any material. It will be designed specifically, maybe 2 3 material you can print on that particular machine. Okay, or you can sometimes as a researcher, you may try to print other material, but it depends. It may succeed, or it may also fail, that you may not the printing cannot be done properly. Okay, yeah. In more complex cases, to have default setting, normally default setting are set like that. You can print the material easily, for which that material machine is designed. Yeah, normally an incorrect setup procedure will still result in a part being uh, built. Okay, yeah. Then once you have set up your machine related parameter, then you will see the build setup uh, before going to the actual build or actual print of your component. Like these may be sometimes you will require interaction. You have to see the product during the printing, whether it is being printed correctly or not, whether your like in this case, let me show you. Let me open that slice data instead of slicing the data. Yeah. So one issue may be that when you have clicked on your print button, and what you notice that your first layer got printed correctly, but maybe it is not adhering. One layer is not adhering with the second layer, or maybe first layer could not adhere with your printer bed. Then the material will you can say it will not printed properly, and your part, or the part which is being printed, it may got distorted, or some other issue may arise. Right. Okay, it is taking time, leave it. Yeah. So once you have completed your during the build setup, you will see where you require manual control or manual interaction and other decision making, whether that your material is getting printed, or your model is being printed accurately or not. Once these steps are completed, the process switches to the computer control building phase, and all AM machine will have similar sequence of layer control, using a height adjustable platform, material deposition, and layer cross section formation. all machines will repeat the process until either the build is complete or there is no source material remaining. Okay, so this is how your once you click on the after completing all machine related all setting all machine related parameter, you can click on the build button and the whole process will be completed. You will get your final 3D printed component. Okay, then uh, then the next step is that once your product is printed, like when your this product is printed on your uh, on your printer, what you have to do, you have to remove this component, you have to remove it from the printer, and then what you have to see, just let me demonstrate one more thing. Yes, yeah. So let me, so with uh, let me show it with support STL file. Yeah. So let me print it with support. Select setting, generate support, overhanging portion. Yeah, slice, cancel slice. Let me change some, make it more thicker, like 3 mm, point 0.3 mm, so that we can, yeah. So for the layer thickness with 0.3 mm, obviously it will take less time. It is showing 12 hours to complete. And let me show the preview of this file now. Here you can see along with your component, you can see support files are printed, because we have chosen we have chosen uh, to print with support. Okay, so that your part is printed accurately. And let me show it from here. So like for layer 1 it is yeah. So this is how your product along with your support will be generated along with your product. Okay, and normally it is done because you cannot print a complex product without the support. Okay, so once you have you have completed your printing process, so what is the next step? You have to remove it and you have to clean it. Okay, so there the output from the AM machine should be ready for use. More often, the part still require a significant amount of manual finishing before they are ready for use. The part must be either separated from the build platform on which the part was produced or removed from excess build material surrounding the part. Some AM process uses additional materials other than that is used to make part itself, that is called secondary support material. Okay, so here you in this printer 2 we are having option that let me show, like select setting. Okay, then rate support, yes, and here you can see uh, you can decide the support material, like support material extruded 2. Okay, so I can choose the support material as from extruded 2, and here you may change, yes, yes, then you, so this option is available in most of the printer, that you can print the supported material in with the different material other than your base material on which your part is supposed to be printed. Okay, so this is called your secondary support material. Then once you have removed and cleaned your product from your 3D printer, there there are, you can say, some post processing requirement, like you may require further processing of that particular product. like you may like finishing, you may like polishing, okay, sandpapering in order to make the surface more smooth, and sometimes you may like to put coating on 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 your uh, printed component. So these all these are your post processing component, post processing techniques, and then your product is ready for ready for use, and then you can use it wherever you want to use it. So this is all about you can say general things about your how this additive manufacturing works, and how your product are created, or how this any product is printed using your additive manufacturing machine, or a 3D printer. Okay, so if there are any query we can take, otherwise we will stop here.